Hey guys, welcome back. Good morning. Hope you're doing well. Today we're going to do more of the same lesson as yesterday, except we're going to step up the level of difficulty in the problems. So here we go. Okay, so on what intervals is f increasing? Okay, well, first, hopefully you remember, f increasing means f prime is positive. And if I'm looking for where f prime is positive, then my goal is a first derivative sign chart. That's what I'm going to try to do. Well, before I can do a sign chart, I have to get the derivative and set it equal to 0 to find my critical points. So notice this derivative is going to require either a product rule or a quotient rule, depending on if you rewrite it. To be honest with you, it's easier as a quotient rule. It's usually easier to simplify it. So I'm going to go ahead and rewrite it as a quotient rule. It's x squared so as a quotient rule, I'm going to rewrite that e to the negative x as an e to the x on the denominator. Now the derivative is a quotient rule. Low, d high, high, d low, draw the line and square below. Low, e to the x. D high is 2x, so I'll put the 2 here and the x here, minus high, x squared, d low, e to the x. Draw the line and square below, e to the x squared. Now notice there's an e to the x in each little group, so we're going to factor out that e to the x, and you'll be left with 2x minus, oops, I should have also factored out an x, I just noticed. They both have an x in common, so I'll factor that out too, what the heck. And now, let's see what we're left with. Okay, I'm factoring out an x and an e to the x, so I'm left with 2 minus x. And now I can cancel an e to the x from the numerator and an e to the x in the denominator. So my current derivative would be, I have an x, 2 minus x, and an e to the x. And now I need to do my sign chart. So when you do your sign chart, you need to set each factor in the numerator and each factor in the denominator equal to 0 to find your critical points. So in the numerator, when will the derivative equal 0? That will equal 0 when the numerator equals 0. So when x equals 0, or when 2 minus x equals 0, which is when x is 2. When is the derivative undefined? That would be when the denominator is 0. And you gotta love when you get e, because e is always happy, positive e. It is never 0, it's always positive. Remember, the graph of e does this, so it never has a height of 0. So when you get e, be happy, because it's always positive, happy e, and this is never, so you don't have to deal with it at all, okay? So that means when I go to do my sign chart, I pretty much get to ignore this guy because it's always positive. All right, so back to my sign chart. I'm going to put the 0 and 2 on my sign chart. Now, check intervals surrounding that. To the left of 0, -1. If I plug that in, and remember, I'm only plugging it into the numerator because the denominator is always positive. Plugging in -1 in the numerator, I'd get a negative, and then a positive, so that would be negative. Plugging in +1, I would get a positive here and a positive here, so that's positive. And now plugging in a 3, if I plug in a 3, I get a positive and a negative, which is a negative. Again, it's not that you can ignore the denominator, it's just that in this case that's always positive, so it's not affecting the sign. So now to answer the question on what intervals is f increasing, well, it's increasing when f prime is positive, which would be this region right here. So your final answer would be between 0 and 2. Okay? All right, let's try another one. Okay, same type of problem, just a little bit uglier with the math. So f is decreasing when f prime is negative. We always write that first. justify it first, always. So my goal again is a first derivative sign chart. Always label what sign chart you're doing because we'll have second derivative sign charts too. Oops, sorry about that. So always label your first derivative sign charts. Always write what you're finding on your sign chart because we're going to have second derivative sign charts too. So we need to find the first derivative, and hopefully you can see that this one requires a product rule. So I'm going to separate my two factors and find their two derivatives. The derivative of 3x is 3. The derivative of this guy is a power rule, chain rule. 1/2. Leave the inside the same, subtract 1, times the derivative of the inside. And that would get you. The derivative of the inside is -1. Now crisscross and find your derivative. And my derivative is going to be this times this, and I'm going to pretty that up, okay? I have a 3x in the numerator, and I have a negative. In the denominator, I have this 2, and this guy would move to the bottom and become a positive. Okay? Now this one. So there's my derivative, but that's not very pretty. And what we're going to do next is set this equal to 0 or find when it's undefined. And when it's two separate terms like this, that's very hard to do. So we practiced this earlier in the year. We need a common denominator, and it's not as bad as you might think. So I basically need to get this denominator over here. So I'm going to multiply by it. Put 1 in the denominator and 1 in the numerator. Okay. Well, now they both have the same denominator, so I'll keep that denominator and simplify in the numerator. I have a -3x. All of this, multiply the 3 and the 2, you get 6. And a square root times a square root is like a square root squared. They just undo each other. Okay, now just distribute and simplify that numerator. So I have a -3x plus 12 minus 6x. So in the end, my derivative would be -9x plus 12 over 2 root 2 minus x. Okay, now set both the numerator and the denominator equal to 0. When the numerator equals 0, that's when my derivative is 0. Solve that. Subtract 12, divide by 9. -12 over -9. Simplify, divide them both by 3, or -3, and we get 4/3. Okay, when is the denominator equal to 0, which is when is the derivative undefined? And that's when either of those factors equals 0, which would be just when 2 minus x equals 0, which is when x is 2. So I have two critical points, 4/3 and 2. And now we need to check the signs surrounding them. But before we get started checking those signs, this square root is like a neon flashing light to me because you can't take the square root of a negative number. So if we plugged in 2 for x, we'd get 0. But if we plugged in a 3 for this x, we'd get a negative. In other words, anything greater than 2 is going to end up giving me a negative under the radical, and you can't have that, which means that basically anything greater than 2 is simply not allowed because you can't take the square root of a negative. So go to your sign chart and say, oops, nope, that part doesn't exist. The graph literally doesn't exist there. Okay, the other thing is, because you can't take the square root of a negative number, this square root is also helpful because when you square root a number, you always get a positive. So again, this denominator is always positive, which makes my sign chart easier if you think about that. All right, plugging in a number to the left of 4/3 would be 0 is easy. When I plug in a 0, I get a positive. Now, what about between 4/3 and 2? You want to be a little bit strategic, okay? Change the 2 in your mind to something that has a third in the denominator, like 6/3, okay? So in between there, we could plug in 5/3. Between 4/3 and 6/3 would be 5/3. So plugging that in here, Negative 9 times 5/3. Okay, and now that you see this, maybe you could think it would have been easier if I changed my denominators to ninths. That might have been easier, but this isn't too bad for me. 9 divided by 3 would be 3. So I have a negative 15 and a positive 12, so that is negative. Okay, so to answer this question now, when is f of x decreasing? F of x is decreasing when f prime is negative, which is between 4/3 and 2. And if you want to see what this graph looks like, graph this on your graphing calculator, and you'll see the graph literally stops at 2. There's nothing happening to the right of it, and it's increasing and then decreasing. Okay? Okay, last one. We are looking for where f is increasing. So again, we're looking for f prime positive and an f prime sign chart. Now I'm going to do my derivative with a quotient rule. So low is x squared. D high, the derivative of 1 is 0. The derivative of the natural log of x, hopefully you remember that, is 1 over x. Okay, oops, I just messed that up. Hold on. Okay, so the derivative of that, the bottom, low is x squared. D high is negative 1 over x, but that's multiplying. Minus high, all that stuff. D low is 2x. I'll stick that right here. Draw the line and square below. Yep, squaring that, you'd get an x to the 4th. Okay, now I'm going to clean that up a little bit. In the first group, I can cancel one of the x's, and I get negative x. I'm going to go ahead and distribute this. Negative 2x plus 2x ln x. And now I'm going to combine like terms. And that's my current derivative. So this is what I have so far, but remember my goal now is to set this equal to 0 and undefined. So if you can factor, you have to factor in order to solve it. So in the numerator, can you see that each term has an x in common? You'll never be able to get rid of the x around the natural log, but the x in front, that I can factor out. So I'm going to factor out an x, and I'm left with negative 3 plus 2 ln x. And in the denominator, I have an x to the 4th. And then one of those x's can be canceled. Okay, there's my derivative. Now set the numerator equal to 0 and the denominator equal to 0. Well, the denominator will equal 0 when x equals 0. And the numerator will equal 0. Let's see when that is. But hold on, time out. Natural log is another one of those funky things. Okay, let me review the natural log graph with you real quick. The natural log graph is the opposite of exponential growth. If exponential growth is this, the natural log graph, I said opposite, that's not technically right. The natural log graph is the inverse, and it's this. So why do I tell you this? You cannot take the natural log of 0 or a negative number. It literally doesn't exist. Nothing at 0, nothing to the left of 0. So for natural log, you have to remember, just like square roots, okay? Natural log, you cannot have an x of 0, and you cannot do the natural log of 0 or a negative number. So when you see natural log in a problem, just like when you see square root in a problem, you want to pay attention to what you're allowed to have right away. So from the very beginning right here, I should have said, ooh, go to 0. No matter what, cross off anything to the left of it because you can't take the natural log of a negative number. Okay? All right, now that means basically this critical point is useless. All right, now let's get back to solving this. Get the natural log by itself, add 3, divide by 2. Now, how do you undo that natural log? Exponentiate both sides. Turn these into exponents. The e and the ln cancel each other out, and you get that x equals, believe it or not, e to the 3/2 power, which is a positive number to the right of 0 somewhat. e to the 3/2 power is a critical point, believe it or not. Now you might think, how in the heck am I going to check the numbers surrounding that? Well, if your critical point is in terms of e, then you want to plug in numbers that are also in terms of e. So in this region here, between 0 and e to the 3/2, I would plug in e to the 1st. In this region over here, I'd plug in e squared. And believe it or not, it's not that hard to plug them in because of the natural log and the e canceling each other out. Okay, so we have to go back to our derivative and plug those in. So plugging in this region, I'm going to plug in e to the 1st. Well, e is like a 3. So in the denominator, that's positive. If I plug in an e here, you'd get -3 plus 2 ln e to the 1st. But remember, ln e cancels, and that just equals a 1. So it's really just -3 plus 2. So that is negative. Now, to the right of e to the 3/2, I'm going to plug in e squared. So plugging in right here for x, -3 plus 2 ln e squared. The ln e cancels, give me just the 2. So this is -3 plus 4, which is positive. So to answer the question, finally, where is f increasing? It is where f prime is positive, and that is from e to the 3/2 to infinity. Crazy. Okay, don't be intimidated. I promise the more you do these tricky ones, the more you get used to it. You're going to have some questions in your homework tonight. Do your best to check the solutions manual to try to figure them out on your own, because it's hard for me to make a video for every problem. So try very hard to figure them out, but then don't be shy about asking me for help and asking me to work out certain problems. I'm expecting that tonight, okay? I'm also expecting this to be a 2-part assignment. We're going to try to do everything tonight, but we'll probably work on it again tomorrow. All right. Good luck.